in a shell, that is in a low-level programming, if you encounter a 00, it means the end of the program, right? Or a termination of a program. So if you encounter this kind of byte, it will terminate. So you have to remove all the bad characters in your payload, right? But let's first create a simple payload, right? So I'll just, if you are to create a simple payload, then you do not need these things, right? That is using MSF panel, MSF Venom, Windows interpreter, Windows reverse shell, reverse TCP, which is Metasploit payload. We are going to create that is this is L host stands for the attacker's IP address, right? And then the L port, which stands for the local port, which is the attacker port, right? And the file format, if you wish to specify, that is, if you are targeting a Windows system, then you have to specify the file format in exe, right? And then output it as a shell.exe. Okay. So for a MSF Venom, that is to build your payload using an MSF Venom, this is going to be one of the simplest payload that which you can create, right? And then if you create this, okay, if you create this, we are not making use of any encoder, right? And also there is no iteration. That is when we create a payload, we can also iterate the encoding over and over again in order to be stealthy and in order to hide itself from antivirus and all to pick up your payload, right? But if you do a simple payload, which is what is written over here, then I believe 99% of antivirus will pick up this, okay? This payload, okay? So shell.exe is just a payload that which you are going to create, right? If you are targeting someone, you have to share this shell.exe to someone, right? And then trick them in order to execute this so that you can have a reverse shell, that is a reverse shell TCP to your system at this port, right? So I'll just copy this selection. Come on. Okay, so you have to make, if you are targeting someone, you have to make your programs a little bit convincing so that people double click it, right? Because even if you send it to them, even if you send it to them, if they do not execute this program, that is a Windows program, which is in an exe format, you will not get a reversal into your box. That's why you have to make this file name a little bit convincing, okay? So that's it. It took some time that is to create a payload using NMS Venom, right? No architecture selected. Selecting that is by default it's selected x86 from the payload, right? No encoder specified. Outputting raw payload. There is payload size of 200 bytes, right? And then the final size of the exe is 73,000 bytes, right? So if you use an encoder, if you use an encoder, if you use this technique of iteration, then keep an eye on this one, right? The more you the more you iterate, that is the more number you iterate, while encoding, the size will become bigger, right? But it won't be that which is a very big, which like it will be a very small in terms of megabyte, so you can keep it anywhere, right? So if I do NLS again, we now have a simple shell.exe, which is a payload for us, right? So what you can do is you can copy this, right? Uh, okay, so let me share this file. Mhm. So let's try to upload this into Google Drive, and in Windows box, let's also access that and download it to check whether that payload will execute or not, right? Okay, so we have this uploaded into our Google Drive. I'll just download it into Windows 10 just to show you, okay, how it should work. Okay, it is saying that simple shell.exe is infected with a virus, and it is notifying us whether we would like to download it or not. Download it anyway, and then right, save it, and go to our downloads folder. We'll have a simple shell.exe, right? So this is the program that which the victim should execute, okay, in order to get a reverse shell into that box, right? So what you have to do here as an attacker, you have to listen it for the incoming connection, right? So let's get uh, four, 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 right? Keep on listening. Let the attacker execute the command, right? I mean that program. Once it got executed, you should expect a reverse shell back to your system, right? Got it? So that's the simple, what should I say? A very simple payload, okay, which you can share to your target in order to get, in order to compromise their system and get a reverse shell into their box. But what you have to keep in mind is that it all depends on your, what to say, creativity, right? How That is how to convince the victim to execute that program, right? It executed, nothing happened, right? But nothing seemed to happen here. But when we go over here, we have a reverse shell connecting to our attacker machine, right? So let's exit from here and then create a new payload using an encoder, okay? And then in order to make use of encoder, I think it's better I show you where encoders are. So if you are going to make, if you want to make use of encoders, you have to go to user, share, right? And then in this share folder, you have a folder called Metasploit, GPLM, Metasploit. Okay, you have to go here. That is Metasploit framework, and in this folder, you will see modules, and inside the modules, we have got an encoders, right? So we have a CMD encoder, we have generic encoder, we have got MIPS encoder, right? PHP encoder, Ruby encoder, Spark encoder, x66, x64 encoder, and x686 based encoders, right? So you can make use of these encoders, right? Any of this. But for today's lesson, let's make use of any one of this, right? I think our Windows, that is our Windows 7, is a 64-bit operating system, right? So let's make use of this 64. Okay, and then we have an encoders written in Ruby. That is four different kind of encoder written in Ruby. So you can make use of any of these, right, to create your own payload. Okay, and also there is one very popular encoder called Shikatagane. Okay, which I think I'll show you. Right, so MSF Venom. MSF Venom. Okay, whenever you want to make use of encoder, you have to specify the switch, which is called E. Okay, that is -E, and then specify your encoder, right? So uh, let's make use of x86 now. x86 okay, output it as okay. So whenever you are going to use an encoder, okay, within this E specify the encoder that which you want to use, okay. So Shikata Ganai is also one very popular encoder in the, what to say, during an olden times, okay. But since people that is many people have started using this Shikatai Ganai, right? That is the antivirus vendor have picked up the signatures that are generated by this Shikata Ganai, and many of antivirus vendor nowadays detect that is the payload which is encoded by this Shikata Ganai, right? But if you do want to use, that is, if you do want to try it out, then you can also make use of this, what is called as Shikataganai, right? And then create your own payload. So, so while this MSF Venom is generating our payload, do you have any question to? Couldn't find encoder to use encoder, no encoder specified. Given NIELIT encoder x86. Shikataganai. We have a spelling error over there, right? SH588. x86. x64. Zito dikiru. Zito dikiru. Zito underscore. Okay, so let's try to make use of this encoder instead of shikaraganai, and also rename this to ZUTO.exe. All right, so that shikadai ganai did not work. All right, and then instead of that we make use of x64 Zuto Dikiru encoder to encode our payload, which is we named this as Zuto.exe. Right, it says that it found one compatible encoder, right, and then it encoded, that is it succeeded, right, with a size of 375. We did not mention any iteration over there, so by default iteration is being used, that is zero iteration has been used, and then we have encoded our payload, and then it is still the same, right? What if I make a, if you do an ls over here, you will see a file called zuto.exe being generated, right? So what if we do like this? That is anywhere if you put iteration is 5. Okay, that is if you want to iterate that encoding mechanism for 5 times, you have to specify I over there, and then specify your, that is the number of iteration that which you want to make use of, okay, in order to make your payload a little bit stealthy, and in order to evade those antivirus and security mechanisms, right? So we specified 5 over there, it went to 5 iteration. For each iteration, it has increased in bytes, but again, that is the final output is still the same over here, right? That is this file is supposed, that is it is meant to like increase in size. Let's check it over. Let's check it manually whether that information is correct or not. Okay, anyway, if it does not increase the size, then that is good for us. That is as an attacker. Yeah, if the size is the same, that is using an encoder, that is using an encoder, and then without using an encoder, right? So that's a good news for us. I think maybe that is maybe MSF Venom nowadays compress the final output, right? Or else for each iteration, we can see that there is an increase in size, that is the byte, right? So any question regarding this? That is using a simple, that is creating a simple payload without any iteration and without any encoder, which is which we did somewhere over here, right? That is, we try to make use of Shikatagana. It did not work. We make use of Zuto Dikiru, that is the encoder, that is without using any iteration, and over here with 5 iteration. And that's the different, that is different ways in which you can generate the payload, right? So any question regarding that?
Sir, do we use different decoder for different device?
Actually, it is not like that, but some decoders are like efficient in a sense that it does not get picked up, and also it does not like create a problem where when generating the payloads. It is simple as that. Okay. You can also embed your payload into what to say, an existing exe file. Suppose say you have a file that is an executable file that which you want to share, right? That may be a game which you want to share with your friend or with your target. You can also using this MSC panel, you can also embed, that is your payload, into an existing executable files, right? And then generate the payload. Okay. And that one will be more promising, right? Because if it is an exe, that is a simple reverse shell exe, then people may not execute it, right? But if it is a game, if it is a program, and you have embedded your payload into that existing game or any application program, then that will be more successful instead of trying these methods, right? So I have to check it manually where we can find any Windows share, Windows, Windows binaries.
Sir, does it only work
Yes.
with .exe extension?
No, no, it will work in any like this one. If it is a Windows, then it will work on this one, executables, right? But in Linux, then it is not an exe, right? It is a different sort of binary. So you have to like mention here, that is while generating the payload, you have to specify your format over here. Okay, that is which format you are going to use, right? So here we have got some Windows program, right? We have got Windows Netcat, we have got keylogger.exe, we have got billing.exe. Let's copy any of this and then let's go to my home. Let's go to my payloads. Okay, what a second. Um, let's go to this. Keep it in our desktop. Okay, so P-Link is a Windows executable program, right? So if you want to embed your payload into P-Link, that is also possible, right? That's how people used to repack their software and distribute it. That is in order. That is when people do a malware campaign, they do those kinds of things, right? They repack their original program. They try to share it, and then they do a kind of malware campaign and then infections, right? So with terminal here, and then let's get a sudo shell. Instead of Venom, let's use a different payload now. That is a Windows uh, x64 interpreter, and then yes. And then okay. So if you wish to like embed your payload into an executable, that is a Windows executable file, that can be done by specifying this X over here, okay, and then specify the program where you want to embed your payload, and then output it as embed embedded.exe, right? And let's try to see whether this command is correct or not. Windows x64 meter MERPRETI. It is saying that the payload is not correct. Okay, so that's how we do. What if I specify I over here? Next iteration, if I make it 5, let's see whether the size will increase, that is, the byte will increase or not. 5,70,120. It's still the same. Anyway, we have already embedded our billing file, I mean billing executable program for Windows, right? So if you share this now, that is, if you share this embedded.exe, which is a billing.exe, okay? When someone executes this Windows program, there is a billing file, which we named it as embedded.exe, right? So when people the target user execute this program, uh, your payload will also get executed, right? So that's how people used to, I mean, embed, okay, malicious program into a genuine and original programs. So this is the reason why people used to say that if you want to download the things, that is, if you want to download a program, you have to download from the original source, that is from the developer site, right? If you are using a mobile phone, uh, people used to say use Play Store, right? And not other source. And this is the reason why people used to share and people used to talk about Play Store and then the original source of the program.
Sir,
Yes.
sir, how do we remove this payloads once it's installed in the system?
Once these are installed, it is a little bit difficult. That is, if you want to do it manually, then you have to find all the artifacts that which you have created, right? Once we execute the program, then so many things happen inside our system, right? Like it creates a registry increase. We don't know exactly what is those malicious software, that is what are its functions. So you have to check for your auto-run programs, right? But the payload which we are creating, it does not have an auto-run functionality. That is, once you exit this program, that is your payload, the attacker will no more have this one. The attacker will no more have access to your system, right? But as an attacker, what happens is that after compromising the system, what the attacker usually do is that the attacker usually migrates the process, right? When we run the program that is a simple shell.exe, if you go to let's do it once again into Netkit. Right? There is a right. So we can see that the process simple shell.exe is running over here, right? Which is an x86 program and is run as an administrator since we logged in as an administrator over there, right? So once this program gets out of execution or you kill the process, the attacker will no more have access, that is to your terminal, right, or your command prompt. But what happens is that if one is making use of Metasploit or one is a very bit technical over here, what one can do is one can migrate the process, right? These are the process, right? Let's share this. Okay, so this is the process that is running, right? If we do, right, so this is a simple shell.exe is running over here, right? Over here in the task manager, we do not find its PID, right? That is a parent ID, okay, or process ID. I mean process ID. So we do not have a process ID number over here. It just shows up some memory that it is in use, and then the description that is the program that is running behind it, right? And the privilege that it have got, right? But if we do a task list over there in a command prompt, right? We have a simple shell.exe which is running at this, right? That is a PID, that is the process ID 2896, right? So people, after compromising the system, what they do is they migrate the process, okay? That is you can migrate, right? Right now we are running as 22,896, but I can also migrate the process to any of this, right? I can migrate my process to lsass.exe, right? lsass is uh, the program that which manage the users, right? Like user accounts, right? So there are many services that is genuine Windows process that are running over here. If you saw this, you suspect that this is something, right? This is not a default, Windows process, so you will kill it, right? So after compromising the system, the attacker migrates to any of these things, right? Explorer.exe is one of the very important process that if you disable this, your Windows, that is your operating system, will get freezed, right? So, and then this Explorer.exe starts up as soon as Windows boots up, right? So one can migrate that process to this Explorer.exe, okay, to hide itself as well as to make it persistent, because Explorer.exe will never die if the system is on, right? So that are some techniques that which people usually do. Okay, I can kill this process, right? And the process, and I can do dir. Yes. You already kill the process. Simple definitions, right? So simple shell.exe is not running anymore. So once I exit out of this command prompt, later on, if I try to connect it back to that shell, I will no more. I will not get it anymore, right? But if people migrated to my explorer.exe and explorer.exe is still running on, then I will get a connection back to my system. Okay, over here. And also, if that's the thing, then it is like what to say, making ourselves, that is our presence, invisible from the victim, right? If you are, I mean, like if anyone out there is aware of it, I am not sure, but if we look at those Iran and Middle East countries, US and Israel, they what to say, they develop they together co-develop a program called Stuxnet, and then through that Stuxnet, they, I mean, like make Iran nuclear facility unusable, right? So that program Stuxnet is nothing but what happened is that after exploiting uh, that is a PCB of that nuclear system. So any question, guys?
Sir, at first we made this payload without using encoders, right?
Yes.
So like, why did we use encoders then? Like, what is the difference if we use it?
Encoder. That is, if we do not encode our payload, it is very much detectable, right? Any antivirus can pick up those kind of what to say, payload. Because what it does is it is just simply opening ourselves. That payload is just simply opening ourselves at port 444, that which anyone can connect, right? So antivirus and all treat those kind of what to say, things as malicious. So it will be easy for those programs to pick up your payload, right? So we that is people make started making use of encoder where our payloads are encoded, right, into some other formats, right? And also it uses iteration that the encoder iterate and iterate and iterate to make our this one payload more stealthy, right? But it is not a guarantee that even if your payload payload got encrypted or encoded, or even if you go through 100 times or 200 times, uh, some good antivirus can still pick up those encoding things, because what they are also doing is they are also making use of MSL venom, right? Antivirus vendors are also making use of MSL venom, right? They are also doing what attackers or crackers or hackers are doing, right? And then trying to generate the payload, the put that signature, that is the payload signature, into the antivirus database. Later on, if someone make a payload using a Metasploit, and they can able to take your, I mean, like, payloads easily, right? And it is not like I'm saying, it is not safe at all. Does someone have a question?
Yes, okay, sir. And sir, like the payload we made for Windows 7, will it work for Windows other Windows version?
Yes, it will work.
Okay, okay. Then if you make this one, this similar one, and then try it on Windows, uh, then it will work, right?
Yes, it will work. If it is there is two architecture, right? x86 and then x64. So you have to identify those two things, okay? 32 it will work in 64, but 64 may not always work in 32-bit, right? So you have to make encoder based on architecture, which is 86 and 64. If it works, if it is a 64, if you generate for Windows 7, that is also 64 based. Windows 10, 64 based, no problem. It will work.
Okay, sir. And sir, about this Ganai and this Zuto Dikiru, these encoders, like what will be the difference if we make payloads out of both of them?
That I cannot also say because it depends on how they encode our payload, right? Like cryptography, just like cryptography, there are many mechanisms like which use XOR mechanism, which use different techniques, right, to encrypt the messages. Just like that, this encoder also use different techniques, mechanism to encode, right? Just like just simple. Let me put it simple, like using WinR and then WinZip, right? They are both for compressing and then archiving, but the way in which they work is a little bit different, right? So encoder, that is Zuto, Dikiro, or whatever it is. Mm, no, no, payload encoder. Share Metasploit framework. Metasploit framework. Okay, so different techniques for encoding this velocino, right? And that is a algorithm that is used. That is algorithm that works and used for encoding our payload is different. Okay. Okay. So Shikata Ganai is x86 architecture and not 64, right? and that's where we did a mistake, right? Shikata is over here, right? And it's an x86 architecture and not 64. We make use of 64 and we specify Shikata. That's why we specify this, but our encoder was here, right? So maybe that is the reason it did not pick up the encoder for us and show us an error over there. So any more questions?
No, sir. Thank you.
Okay, let's take a 5-minute break and then we will discuss, that is theoretically discuss something about buffer overflow, okay? So let's take a 5-minute break and come back. Are you guys back?
Yes,
Yes,
sir.
sir.
Okay. Let's discuss now a little bit about buffer overflow, okay? We have done buffer overflow attack, right? When we try to exploit mod SSL, when we try to exploit Samba, in all those exploits, uh, that is, those exploits were vulnerable to what is known as buffer overflow attack, okay? And then we did that, but we did not we did not go into detail what a buffer overflow attack is, okay? So suppose uh, so this buffer overflow attacks occur when there is like a improper validation and improper sanitization. That is the boundary. That is a boundary check. Okay, if we do not keep the boundary check, what happens is that in a program, whenever we try to do something, buffer is allocated uh, to that. That is a buffer. That is the memory area. Some memory area are allocated for that particular process or executable to run over there, right? Or while accepting an input or an a variable, what happens is that if the limit is not checked, then that is the buffer overruns. And one buffer overruns, what happens is that in a stack-based program, it overruns instructions that are to be followed, right? So that kind of vulnerability is called buffer overflow vulnerability. Okay. So the definition, it says an information security and programming, buffer overflow or buffer overrun is an anomaly where a program, while writing a data to a buffer, overruns the buffer boundary and overrides adjacent memory location. Okay. And then buffer are areas of memory set aside to hold data, right? That which we all know, right? Being a technical student, I think we should not go into details and then waste time on this, right? So often while moving it from one section of a program to another or between the program. So this is the definition which I got from a wiki about a buffer overflow. Okay. So what are buffers? A memory storage region that temporarily holds data while it is being transferred from one location to another, right? So basically, there are two types of buffer overflows, which is stack-based and heap-based. Okay. Some people say that there is three types of buffer overflow attack, right? But here we are discussing about two types of buffer overflow, okay, which is a stack-based and a heap-based buffer overflow. So if someone asks you what are the possible types of buffer overflows that can happen, then you should answer that it could be a stack-based buffer overflow attack, it could be a heap-based buffer overflow attack. And then stack-based buffer overflow is very common, okay, in programs, and also to exploit this stack-based buffer overflow, it is easier, right, than performing an exploit against a heap-based buffer overflow. So you guys are familiar with C and C++ programs, right? And then that is often we use functions which are printf, as printf, string get, string copy, gets, right? These are some functions that is common functions that which we use in C and C++, right? And also in other programs. Right? So have you ever used these kinds of functions while programming, that is coding your programs?
Yes, sir.
So
Yes, sir.
have anyone ever told you not to use these kinds of functions? Or if are used, you have to use in a proper way, that is doing a proper sanitization and validation. You have to make use of these functions, right? These are some common things that we cannot evade sometimes. But if you are making use of these functions, be careful, because it says that they don't have a built-in safeguard against overwriting or accessing data in the memory. Okay, so if you are not making use of these functions, it is possible that your program will have a buffer overflow vulnerability in your program. Okay, a buffer overflow occurs when the size of data exceeds the storage capacity of the memory buffer. Right, that is why it's called buffer overflow. As a result, a program will try to write a data to the buffer, which overrides near memory location instructions pointer, right? So next to the buffer, if it is a stack-based buffer overflow, there will be that is adjacent to your buffer will be an instruction pointer and then the base pointer, right? It will override the base pointer first, and if there is still data, then if there is more data, then it after overwriting the base pointer, it will override instruction pointer, right? And like I have been saying, instruction pointer stores the next instruction that which is to be executed. So by overflowing that, if the next instruction which is to be executed is overrun, what happens is that the program crashes, right? That is, if instruction pointer stores the address of the next instruction which is to be executed, if that address is overwritten, then what happens? Your program will crash, right? Your program will become not only non-responsive, but it will close away, right? And if it closes away, it means that the buffer has been overrun, right? There will be some error may pop up saying that there is an access violation, right? If you can across that kind of programs, then like saying claiming that the program crash and it claims that access violation has occurred at some point, that is any address, it is simply a buffer overflow. Okay. So have you guys encountered any situation like that? That is while running a program, the program crashes and it pops up that there was some access violation, something, or while coding as any program in any language, right? If you are coding something when you run, and then if you come across, right? So if you are using an IDE for development, then access violation, that is the complaint about access violation will usually pop up at the bottom of your screen, right? Or if it is a program, then there will be a pop-up which says that the kind of pop-up which will say that access violation have occurred. Okay, so here is an anatomy of a memory. So in a memory, when we discuss about it, we have a kernel, and below that kernel we have got a stack, a heap, data, and the text, right? So for our course, that is for our training, we will discuss about this stack, okay? And then the anatomy of the stack, that is deeper into the stack, we have got ESP, that is extended stack pointer, right? That is the starting of the program or starting of any functions, right? Or any instructions, right? And then we will have a buffer, the buffer space where it has to accommodate some data, right? And once this execution is done, right? That is at the end of the buffer, we have got extended base pointer, and beneath that is EIP. Okay, so there is so many things that which you need to perform to uh, you need to do to perform a kind of what is it buffer overflow attack, right? You need to find out what is the buffer size, that is how much up to how much bytes this buffer is accepting, right? At what that is at what byte it is overwriting this that is this EIP starts, at what point this EBP starts, at what point that is in which location, that is in which memory location does this EIP starts. So those are all the things that which we will discuss one by one, right? EIP is also called a return address, right? Okay, so in order to conduct that is a buffer overflow, these are some few steps that which you have to follow, right? First and foremost, what you have to do is do a spiking. Spiking and fuzzing, they are almost all the same. The difference is that in a spiking, what we do is we just throw random data bytes, right? Unlimited bytes to the program to see whether the program will crash or not, right? We will throw unlimited number of bytes to a buffer. We will see whether it will crash or not. And then in the fuzzing also, in the fuzzing process also what we do is we throw uh, bytes to the program, that is the program buffer. But in the fuzzing, what it does is it does in a limited way, right? In order to find the offset, that is to check and to sum how much byte that buffer is accommodating, right? After once it is done, what we have to do is that we have to find the offset, right? We have to find the offset for the EIP, right? Where EIP starts. And once we find out our EIP offset, we will override the EIP. That is, okay, so we will override an EIP. Once an offset of an EIP has been found out, what we have to do is we have to override the EIP, okay? That is the return address which is present in the EIP. And then we have to supply our payload, right, address to that EIP so that after executing the buffer, that is the program that are in the buffer, it have to jump out of that and it have to go to EIP. So we replace the EIP with our own address, that is our exploit address, right? And then we'll also need to find out the bad characters in there, right? I talked about the bad characters, which was 00 in hex, right? So if there is any bad characters that are present in your payload, you have to do away with those bad characters, because if that is present in your payload, your exploit will not be successful. So you have to remove all those bad characters, and then you'll find the right model. After that, you need to generate the shellcode. After generating the shellcode, you need to replace the EIP with the shellcode address. And once the EIP got executed, that is EIP points the instructions towards your shellcode. Then what happens is that in the end of this, um, you will get a root shell, right? If you are trying to get a shell, then you'll get a shell. If you are trying to execute something more, then that can be performed out there, right? So are you guys getting what I'm trying to say?
Yes, sir.
So basically, what you have to do is you need to know how the program works, right? So in order to know how the program works, these are the steps that which you have to do, right? Spiking fuzzing, right? And then once you know how this program is behaving with those bytes, you have to uh, do something, right, in order to hijack. It is nothing but hijacking. We can say a hijacking of the program in the execution, right? That is override the buffer, replace the return address with your own, and then once that return address got executed, your shellcode will get executed. Once your shellcode get executed, you just simply hijack the program, right, from its normal execution. So that's how a buffer overflow should be performed, right? So I think I'll share one program with you guys. Okay, do you guys have a Windows installed into your VM?
Yes, sir.
So if you have a Windows installed into your VM, I will share some program with you with which we will do, that is perform this buffer overflow, okay, attack, and then we will trying to gain the root after exploiting the program. Okay, so what you have to do is you have to go to this site called immunityinc.com, okay, and download an immunity debugger as per your requirement, okay. Go to this section, just simply fill up these things. It is not supposed to be like doesn't matter if it is correct or wrong, and then just click on download, okay. They will not check and validate these things, so just fill up this form, download an immunity debugger, and install it into your Windows operating system which you have in your VM, okay. You will have something like this, right? If you are installing Windows 7, if you have installed the Windows 7, then just run it and install Immunity Debugger India, okay. If you have Windows 10, it's not a problem as well. So install Immunity Debugger in whichever Windows you are using. And also I'll share one program in WhatsApp. Oh, I think I can also share now. Okay, so if you have installed okay, get this link, download a vulnerable server. It's an application. Installation is not required. It's a portable program, so you don't need an installation. You just need to double click an executable file in order to run that program, okay. So set up your and get ready with your VM, and tomorrow we will see how to perform, that is how to perform spiking, how to perform fuzzing, how to find an offset, right, how to overwrite an EIP, and also how to generate a shellcode, okay. We'll also see how to write a shellcode. I think you guys are familiar with Python, right?
No, sir.
How many of you out there are familiar with Python?
Sir, very basic stuff.
Very basic stuff like how to program those console application.
No, not even that, sir. We just did some analysis part using Python.
What kind of analysis?
Sir, just those alg algorithm type like KNN and all.
Okay. But the program that which we are going, the program that which we are going to code is we are going to code it in a Python. It's going to be a very simple program. It's for each and everything. It's going to be a very short program, right? If you are not familiar with it, then I can just code it and I can also share it with you guys how to so that you can have a program with you and then we will do it together. Okay, like most of the program will be just a few lines, that is 3 to 4 lines. It's not about the pages and pages of lines. It's just a 1 or 2 line which we will need. And then okay, anyway, let's I think it's better if we start afresh tomorrow doing this buffer flow, right? Or do you guys
Yes.
want to try today itself?
Tomorrow.
Tomorrow. Okay, then just what I want you to do is configure your VMs, okay? And get ready. I'll just, if possible, share those scripts as well. That is a Python script, and we will get to it together tomorrow and do the things together. Okay?
Okay, sir.
Okay, sir.
Okay, then we'll see you guys tomorrow at the same time.
Okay, thank you, sir.